All right, we're continuing off from the notes that we were taking in class. Okay, so we were on step 3, and then we just graphed. What we graphed is we graphed a vertex and then 2 other points to make a general parabola that we know opens up. And this is technically the graph for this is the graph, the visual graph for y is equal to x squared plus 2x plus 4. But remember, we're actually graphing an inequality. Y is less than or equal to x squared plus 2x plus 4, or 1x squared plus 2x plus 4. It's the same thing, okay? Or it looks like this. It's this part and this part of the same thing, but the equality sign is now replaced with an inequality sign, okay? So here's how I'm going to do this. First, I'm going to give you the next step, all right? I'm going to explain what you're basically going to do, and then I'm going to explain what it all meant at the very end, all right? So your next thing is to test maybe a point. So you have to pick 2 points. You have to pick 2 more points to test, and you have to pick a point that's either below the parabola and above the parabola. Okay. So in this case, I'm going to choose to do negative 1, 5. I'm going to make it easy for myself. Pick a point that I think is easy. So I know that the vertex was negative 1, 3, right? So I'm going to pick a point that's 2 points above, and I know that's not on the line. So again, you have to pick 2 points to test that are not on the parabola. So I know that negative 1, if you go up 2 spaces above, there's no way that's on the actual line that I drew, okay? So what we're going to do is we're going to plug this into the original equation and see if it makes this statement true, okay? So the equation is y is less than or equal to x squared plus 2x plus 4. And then what I'm going to do is I'm going to plug in all these numbers, or I'm going to plug in 5 because that's my y value. I'm going to plug in 5 where y is. I'm going to plug in negative 1 where x is. So let's do the math really quick. 2 times negative 1 is 4. And that's going to be 1 plus negative 2 technically plus 4. And then that's going to give me, let's see, 1 plus negative 2 is negative 1 plus 4. I believe that will be 3. Okay, so now I have to assess, is this a true statement? Is 3 greater than or equal to 5? This is not true. Okay, so basically between both of these points, so I'm going to pick another point, negative 1, and now it's a point that's going to be below the parabola. Let's go ahead and try one. So I picked negative 1, and I know that negative 1, 3, which is the vertex, is the lowest point on this parabola. I know that there's no point on this parabola that goes to negative 1, 2. So I picked a point that was above. Now I pick a point that's below, and I'm going to do the same thing. I'm going to kind of just substitute in for y is less than or equal to x squared plus 2x plus 4. I'm going to substitute in these values into the x and y positions. Negative 1 squared plus 2 times negative 1 plus 4. Okay. Let's see what I end up getting. That's going to be 1 minus 2 plus 4. 2 is greater or less than or equal to, let's see, that's negative 1 plus, okay, so that's going to give me 3 as well. And this is actually true. What this means is wherever you pick, so I picked a point above and below the parabola. What this means is wherever your points are true, you're going to shade it in. So I picked a point that was below the parabola. So that means when there's a point below the parabola, below any points on the parabola, I could have picked like negative 4, I don't know, whatever this point is below up here, okay? As long as it held true, I guarantee you now at this point, if you plug in any point below this parabola, I just picked 1, it will hold this statement true. It will make it so whatever's on the right side is going to be greater or equal to whatever's on the left side, the y value, okay? That's going to be true, and I guarantee you that any point above the parabola, if I plugged it in, will make this untrue, okay? And I have to shade in the region where all the points are true. Okay, so what does this mean, okay? So the first thing I did was I just showed you how to do it. Now let's understand what you just did, all right? So I'm having to graph an inequality, okay? Normally, if I graph an equality, y is equal to x squared plus 2x plus 4, I'm asking you to show me all the points that represent whatever will make this true, right? Whatever this whatever the statement is. So it's y is equal to x squared plus 2x plus 4. All these coordinates, so basically all these coordinates on this line will make this statement true. All these coordinates will be such that if I plugged in the y and I plugged in the x values into both of these positions, the numbers on both sides will always be the same. So basically, this is telling me all the points on this line only, okay? However, this graph isn't just asking for the points just on the graph or on the line necessarily. It's asking for any points that are on the line, as well as giving me this weird statement where whatever my x's, whatever my coordinate is, if I plugged in the x's on this side, it would make a number that's bigger than the y values on this side. Okay, that's all it is. So what this shows me is that, okay, all these points on here make this statement true, and all the coordinates and points below, okay, if I plugged in any of the coordinates, okay, like I said, like -1, 2, or let's go even further, like negative or like +1 comma all the way down to like -10, if I plug that in here, I guarantee you that -10 on this side and I plug in 1 on this side, positive here, this side's always going to be greater or equal to the y value, okay? So that's basically all I'm asking, right? And that's how you do this test on these graphs, right? So this is a situation where you graph an inequality where y is less than or equal to some kind of equation with x on the right, right? Right? No pun intended. But what if it was just a straight greater or equal? I'm sorry. Greater or equal to value? Meaning, what if I was given another example, like what I'm about to give you, like this? Y is just less than -2x squared plus 3x plus 5. Okay, what is that going to look like, and how is that going to look a little bit different, right? Well, it's the same steps. So let's go back to, let me see. Whoops, just kind of put that away. So the first big idea is to just graph initially like normal. So you're going to graph the line y is equal to -2x squared plus 3x plus 5 like normal. So let's make that a little bit more clear what I mean by normal. I'm saying like how about you normally do, like you normally do, okay? Like you normally do, okay? So that means first you got to find a vertex. So you got to find the vertex. In this case, I know this is my A, my B, and my C, and I know that my vertex, the x coordinate has to be -b over 2a, which is -3 over 2 times -2, which is -3 over -4, which is 3 over 4. Okay, and the vertex is a coordinate. All right, so I know the first part of the coordinate is 3 over 4. The y value is you just plug in this into, you plug this into the actual equation in here, okay? So that's going to be 2 times 3 over 4 squared plus 3 times 3 over 4. Oh, this is going to look pretty nasty here. Plus 5, okay? So this will take a little bit of time, so let me just work through this, okay? Oh, and it's -2, so it's -2 times 9 over 16 plus 9 over 4 plus, and you know what? Why don't we rewrite? So it looks like the greatest common denominator will end up being 16, okay? Because I know this is over 4. I'm going to make this with a denominator 4, so I'm going to multiply both the numerator and denominator by 4, okay? Because I'm not changing the value. I don't want to change the only the bottom value, like times 4. Because that changes this whole fraction in the value of the fraction. So if I multiply the bottom by 4, I have to multiply the top by 4. Same thing with 5. I'm going to multiply it by 4 over 4. Okay, and that's going to give me 20 over 4. So if you think about it, the fraction of 5 would be 5 over 1, right? So think of this line. Let's divide both those areas of work, okay? And this is 9, and this is 4 to clarify, okay? So you have -2, okay? It's a whole number times a mixed fraction. You're going to multiply this by the top number. That's -18 over 16 plus 36 over 16, and then this is going to be plus 20 over 4. Oh, you know what? I'm sorry. And I did make a mistake. So the common denominator, again, was 16. I only multiplied 5 over 1 over times 4 over 4. It should have been 16. So I do apologize. 16 over 16. So this makes this a much bigger number. I believe 5 times 16 in my head is 80 divided by 16. I'm just kidding. It's not in my head. It's in my notes that I'm writing off of. Okay. This is going to be 80 over 16. Okay. So I do apologize. So let's add all this together. I'm going to add the positive numbers. Actually, no, I'm not, because I understand that negative 18 plus 36 over 16, they're going to have the same denominator. 18 I know is already half of 36, so that's just kind of quick math. So if I added the negative 18 to this, I would get positive 18 left, plus 80 over 16. That gives me 98 over 16, which I'm going to say is approximately 6.12. Or it's not approximate. If you actually plug this into your calculator, you get 6.125. And you know what? I'm going to put that here, but I don't like how this is 3 over 4, comma 6.125. If I were to write this as a decimal, you put this in your calculator, 3 divided by 4, you get 0.75, comma 6.125. Again, what you just found, all that math was just for the vertex, okay? So the next step is, so we're building this parabola. You need to find 2 other points on the parabola. So let's just see. Let's see here. What is another possible point? Let's do 0. I don't know. Let's just do x equals 0. That sounds pretty easy. Okay, and let's plug it into y is equal to negative 2x squared plus 3x plus 5. So it's negative 2 times 0 squared plus 3 times 0 plus 5. That's pretty nice. So that's why I picked an easy number. So that'd be negative 2 times 0 plus 0 plus 5. That would just be 0 plus 0 plus 5. That would just be 5. So we have a point at 0, comma 5. All right. And let's pick another point. X is equal to, I don't know, like 1. Let's make it really, really simple. Okay. X is equal to 1. So y is equal to negative 2 times 1 squared plus 3 times 1 plus 5. Whoops. Let's see, we can get that on camera. So that's going to be negative 2 times 1 plus 3 plus 5. That'll give me negative 2 plus 3 plus 5. And let's see, that would give me positive 1. So that would give me 6. So I have 1 comma 6, right? So let's go ahead and graph this. This isn't the last step, okay? So let's do equal increments 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. Okay. It's really hard to graph the vertex, so I'm going to try my best just to do it by eye. So it's not exactly at 1, but it's at 1, 2, 3, 4, 5, 6. It's a little bit above 6 here. So I'm going to say the dot is right there. Okay, so I'm going to extend my graph a little bit. So that's 6, 7, 8, 9, 10. So I'm going to say 6 is right. So that's the vertex right there. And I know that if I look at my A value, that's telling me that my parabola is going to open down. Okay, so I know that the vertex now is going to be opening down, not up, but it's going to be opening down. So the vertex is now the highest point on this graph. Then I'm going to do 0, 5, which is really easy. I just go to x value of 0 and I go count up 5. 1, 2, 3, 4, 5. Okay, so that's going to be this rough parabola, that first half. And the other one's going to be 1 comma 6. So I'm going to do 1, 2, 3, 4, 5, 6. It's actually going to be right next to this this side here. So there we go. That's my that's going to be my parabola. Okay. But all I really technically graphed is this. I only graphed y is equal to negative 2x squared plus 3x plus 5. I need to graph the points that are going to give me a statement in which my right-hand side is going to be greater than my left-hand side y value, okay? So I need to find the coordinates. Either it's going to be all these coordinates up here or all these coordinates below the parabola, Okay, so I don't know. I have to test some points to see. Okay, again, if I graph y is equal to, it would only be y is equal to whatever this equation is on this side. These are the only points that make that statement true, the points on the actual line. But I'm looking for the points that are going to be less than y. Okay, so let's go ahead and go to step number 4, which is to test 2 points. And those 2 points have to be either way above or, just somewhere out here that is nowhere on this line. Because I only know 3 points that are for sure on this graph. The rest are just kind of like, I'm not really sure. So I have to pick a point that I know for sure cannot be on this line. There's no chance it could be on this line. So I like to pick like the same x coordinate, which is like 0.75. Well, actually, that's pretty tough. Let's go to 1. Okay, let's go back to 1. X equals 1. But then let's pick like a y value that's like way out here. That's like way above the vertex. Okay, so let's do like 1, 10. Why not? So let's say 1, 10. So I'm going to pick a point that's above the parabola and one point that's below the parabola. So I'm going to do 1, 10. And you know what? I'm going to stick with the same like x value here and then go way below instead. How about 1, 0? That seems really easy. I like that one. So the difference between these 2 points is 1 point is above the parabola, 1 point is below the parabola. And let's reiterate, the equation is negative 2x squared plus 3x plus 5. And the other one is going to be the same thing. Only it's an inequality, so it has to be y is less than, it's not equal to, but it's less than negative 2x squared plus 3x plus 5. Sorry, I had to fix that. Okay, so let's plug in 10 where y is and then 1 where x is in this equation or in this expression. 10 is less than negative 2 times 1 plus 3 plus 5. Or it's not negative 10, it's just positive 10. Positive 10 is less than negative 2 plus, let's combine 3 and 5 really quick, 8. And then it's going to be 10 is less than 6. Is that true? That is not true. So I can already expect that we don't shade up here. Okay, we don't shade up here. And then over here, let's try this. 0 now goes in y, and let's plug in 1 in here. For my inquisitive students, you might have already realized I did all the work for when I plugged in 1 all over here. It's going to give me 6, but why not? Let's just go through it one more time. So it's going to be negative 2 times 1 squared plus 3 times 1 plus 5. That's going to give me negative 2 times 1 plus 3 plus 5. 0. I could do it the other way where I have negative 2 plus 3 plus 5. And I'll do it like the way I started in the video, which is negative 2 plus 3 is negative 1. Positive 1 plus 5 is still 6. This is true. So this tells me that I have to shade I have to shade the region below the parabola. So hold on, wait a minute. There's something wrong with this graph that I did not go over. Remember, this is an inequality that is not equal to y. So technically, I'm not asking for the points that give me y is equal to negative 2x squared plus 3x plus 5, which would be all the points on the line. I'm not asking for those points, am I? I'm asking for only the points that are going to be below the parabola or above the parabola, or basically any points that make this statement true. And guess what? I don't want any coordinates where they actually make them equal to on both sides. So that means this line, what we're going to do with this line should not be solid because I don't want it to be solid. I'm going to kind of make it like dash. I'm going to dash it. So you can erase the line if you did it in in pencil, because when you're in marker, you're going to have to do what I did. Basically, this is a dashed line. Because what it's saying is I'm not including those points. I'm not including those points on that line that make this an equal statement, okay? Because earlier, I had you graph. Let me see if I can grab that. Earlier, I had you graph y is less than or equal to x squared plus 2x plus 4, right? So that means the points on this graph make both of this statement, like this side and this side, equal to each other, and all these points below it make it to where the right-hand side is when you plug in the x value of from the coordinate into here, that's going to make this side greater than the y side, right? So I asked for both the points on this line and the points, okay, that make this y is less than statement true. But here, what's different is I'm asking just for what points make that this less than statement true. And it's not these points on this graph. That's why I dot it. I kind of let you know like fencing, like, hey, this is like a general fence. Like below this fence are all the points that matter, but the actual fence itself does not matter. Okay, it should not be included. It's not included in this statement. I'm asking again. I'm asking you to graph the points that make this inequality statement true. Okay, but I am not asking for the points. I am technically not asking for the points for you to graph the points that are actually going to make this an equal statement. And that would be the actual line. If I did ask you for that, this line would be solid, but I'm not. I'm just kind of showing a general fence where the actual points are going to be below or above, okay? Hopefully that makes sense. I'm going to stop here for now. There's going to be a part 2 for this section, and you guys take care, okay? Hopefully that helped out a bit, if anything. Bye.